All right, here's the last one for this type of problem. An angle is shown, 70 degrees. State another angle that has the same cosine, but a different sine value. So the cosine here is going to be the same, but our sine is going to be different. Now, in order to have a positive cosine or x value, we know that it's going to be in quadrant 1 or quadrant 4. I'm going to try something that I did in the last experiment. So we want it to be 0.34 as our cosine, and we know that this is 70 degrees here. So I'm going to find the mirror image, except I'm going to mirror it off the x-axis here, and I'm going to go down 70 degrees, okay? So I could try negative 70 and see if that works. I could also try 360 minus 70, which would give us 290, and see if that works. So let's go ahead and try the negative 70 degrees first. Cool. So that worked. It gives us the same cosine, but a different sine value. It's negative here. Let's also try 360 minus 290 and see if that works as well. Great. So 290 seems to work as well. You could also try 360 plus 70 and go around and see if that works. So 360 plus 70 gives us 430. Oh wait, that wouldn't work because it's the same exact sine value as well. But fourth, let's see, 290 plus 360. Trying to do this in my head. 640 should work. Guys, I don't know what's going on with me. I can't do math as quickly as I used to be able to. So 650 does work as well. Again, you could do another full rotation and see if that works. There's many different ways that you could answer this problem and still get a correct answer. Okay. Now, we're going to go on to the second part of the unit circle, which is radians. Okay, so another way to measure angles in a unit circle is through radians. We looked at the cosine and sine, the x and the y. Now we're going to look at another way that this is used, the unit circle is used, and that's radians. And the radians, which is the distance from around the circle, measured anti-clockwise from 1, 0. So we're going to start again at this point here. Remember that this is a unit circle, so the radius is 1. What is the distance around the circumference of the circle? So they want you to find the total distance around the whole circle. Hint, you can type pi to get the pi symbol. Now, I want you guys to play around with this and try different numbers and see what happens, okay? So how do we find the perfect number that works here? If you're having trouble with this, what I want you to do is to think about what you learned in geometry. Okay, so in PANU or in Harlan's class, you learned that the circumference is twice the radius times pi, or you could say 2 pi r. They tell you here that the radius is 1, okay? So knowing that the radius is 1 here, what would the circumference be? I'll give you guys a second to think about that. Okay, so you should have 2 times pi times 1, which will give you 2 pi. So given a unit circle, we know that the total circumference around this circle is going to be 2 times pi, or 2 pi. Okay, that's something to remember. So we know that this is 2 pi. If we know that that is 2 pi, what do you think half of the unit circle would be from here to here in radians? Okay, so just think about that for now. How do I clear this? Okay, cool. All right, so this point is shown on the unit circle. What is this angle in radians? I want you guys to think about that for a second. We know that the total is 2 pi. What do you think half of that would be? If you said 1 pi or pi, you are correct. Now, to go from 1 pi to here, what would we have to do? And we're going to continue this in the next video.